All right, let's talk a little bit about detection of radiation and its biological effects. A lot of times we use gas ionization counters to detect radiation. The gas goes into the wand where you have an inert gas. That gas is then ionized and therefore is attracted towards electrical electrodes, which cause a change in the electricity. That change in the electricity is measured as a count of a radioactive particle. It has to be high enough energy to pass into the detection wand and ionize the gas and be recorded. So you're talking about beta and gamma, not alpha. Sometimes you have windows you can open and close, where an open window would measure beta and gamma, and then close the window to block out the beta, and the gamma will still penetrate, and so you get just the gamma, and you could subtract to get the beta. If you're exposed, there are, of course, adverse health effects. Gamma radiation is usually the one you worry about because it can travel much farther and it's much higher energy than beta or alpha from an external source. Radiation absorbed can cause excitation if it's non-ionizing radiation, or ionization if you're talking about ionizing radiation. And that ionization is going to be much more harmful than non-ionizing radiation. It'll causing tissue damage and cancer and all sorts of adverse effects. So what happens from an external source, the alpha has trouble penetrating and bounces off. The beta will penetrate somewhat and can cause tissue damage. The gamma will pass straight through you, causing damage all the way through your body. So gamma is usually the one we worry a lot about from an external source. The SI unit is the becquerel. A becquerel is a disintegration per second. Sometimes we use curies, where a curie is 3 times 10 to the 10th disintegrations per second. The rate of decay of 1 gram of radium is equal to a curie. That is really radioactive. If you're the average person, this would be your radiation exposure on average. Radon, which is naturally occurring, particularly if you got basements or live in a rocky environment, you kind of have to worry about radon. And that's over half of your exposure. Rocks and soil, there might be trace radioactive elements in the rocks, particularly if you live in a more mountainous, rocky area. Cosmic rays from the sun, radioactive isotopes in the body. So other than maybe avoiding radon exposure by venting your basements and whatnot, there's not a whole lot you can do about some of these things. There's certainly man-made sources like medical x-rays, nuclear medicine, consumer products, but they make up a relatively small amount for most people. But those are ones you can kind of control a little bit more. Radon is, again, most of our exposure. It's a decay product, uranium-238. So if you get uranium, even if it's not a prospectable amount in the rocks, it can contribute to radon in your basement. If you live in some of those high-risk areas, you want to usually have some ventilation to turn the air over in there so that the radon doesn't accumulate. But it does have a half-life of 3.82 days and decays to polonium, which is solid, where radon's a gas, plus an alpha particle. Now, we talked about alpha particles not doing much damage from an external source, but if you ingest it or inhale it, it can be quite damaging because it doesn't have to penetrate to get to something that's going to do damage. So if alpha radiation can get to something where it can do damage, it actually does more damage than gamma or beta because it's a much heavier particle. And we call that a relative biological effectiveness, about 10 times more damage. Inhaled radon is therefore thought to cause lung cancer. But then the polonium is also radioactive after it becomes trapped in your lungs and produces a second alpha particle, which ends up in lead. Now lead's in your lungs, so that's not a good picture all the way around. EPA recommends radon be kept below 4 picocuries per liter of air. This is from the EPA. This shows radon risk zones throughout the country. The reds are obviously bad. They're more rocky, mountainous terrains, the reds and the oranges, where the yellows tend to be a little bit more coastal areas in general, but definitely not any sort of uranium in the rocks. I'm located in South Carolina, and you can see there's a little swath of orange and pink in the upper part of the state, where the lower part of the state is pretty low risk. We can see it following the Appalachian Mountains there. And then once you get into the Rockies, you see a lot of orange and pinks as well.